I love to come. Okay. Come on, everybody loves to go to. Anyway. Who's that? I heard about that. No longer is it on that network. Now it's on like a pay-per-view network or something like that. Sesame Street.
News today.
And I heard it changed. Anyway. All right. Well, I still always will remember Sesame Street fondly. There we go. Okay, so yeah, separate first and last name. Now, obviously, as I was saying, there are lots of other things we could think of that you might track about an employee, but thinking about the information we were given in that sample little report that we had, that's all that's mentioned. So in the real world, what you'll often do is you'll sit down with a client, right? And you'll say, okay, at this point it looks like this is what we're gathering in terms of information about your employees. Is there anything else you anticipate you want to start tracking and so on? And you might expand the list. But basically, that's a correct answer and that it satisfies the needs as we currently understand them. One thing about specifications and needs and so on of a client, they're always changing and updating as time goes on anyway. So it's never that there's a right or wrong answer. It's a good enough answer for now, and we'll run with it, right? So that's basically what it comes down to. So you have something like that, then you're good, right? Okay, we'll skip over. If there was time, we'd go through and talk about a car and a restaurant, and I'd come up in the board and we'd put on ideas and so on how you'd model a car and what would you track about it. But you can get the idea. I mean, it depends on, do you need to know absolutely everything about a car or just the most important pieces? And that's where it comes out of a discussion with your client to see what it is their application needs to track. Right? So from the beginning to the end point, right, we started off with, I know you can't read this from back of the room, but if you watch the video, you should be able to read it. An example of what a report might look like.
How are you recording?
It's magic up my sleeve.
But you don't have sleeves.
Yeah. It's a little microphone over there, so I should probably talk like this as I point, but if I could have it on this screen, it would be much better. Then I could stand here and face it, but it's a pretty good microphone. It's one of those blue ball things, By the way, if anyone gets out of line, I can hold up. There's a little ray gun built into it, and I can blast you. Okay?
You lost me a blue ball.
What?
Oh, you've never had blue ball? No. Blue says right on the front.
Oh.
Okay.
Okay.
Yeah, now you get it. Yeah, okay. All right. There we go. Hopefully that's recording. Actually, I can see over here that it is. Okay? Okay, so it's recording the screen and my voice. And I'll put it up on YouTube.
Gotcha.
I have a channel. No ads. All right, so from that model case then, we came up with a concept for what our entities might look like. Okay, we did department the other day and now employee and so on. And then to start translating that into a database system though, what we'll next usually do is not shown here. We'll make a table design chart, right? Where we list the fields, what data types we might have and their sizes and so on, and any constraints that we might have about them. Because eventually we want to be able to hold the actual data from the client in a real table. So when we talk about a table, obviously there are things that go into making up a table. Now this is stuff you've known from grade 4 probably, right? Columns and rows and all that kind of thing. So there's nothing too much there. So our attributes, when we're sort of modeling, we create entities and their attributes. Those attributes become columns in this theoretical table. We often refer to them as fields as well, database terminology. Fields, columns, I can accept either. I'm not going to penalize you if you use one or the other, okay? And obviously each row in a table is essentially, in object-oriented terminology, an instance of that entity. Or we'll just call it a row. If we're feeling casual and just want to be friendly, talk about every row of data, right? Instead of every instance of the department. So that's basically it. Now, when you look at the data, though, you start to think about, well, how am I going to store this? What sort of a data type? You're familiar with other programming languages, I'm sure. Most of you did some, even in high school, some languages of one sort or another. So you're familiar with the concept of data types in computer terminology. What are some of the common data types you've worked with in the past?
Integers.
Integers, sure.
Characters.
Characters, right. Okay, so those are the main two groupings. The other one, third one is date and time, right? And there's others, okay, but really they fall into those main classic numbers of different sorts. I mean, you might have floating point or integers and big integers and all kinds of things like that. So we've asked you, or I will ask you before our next class, to review a couple of videos that are online that talk about some of the common SQL Server data types that you're going to be using. And we'll show you today, we'll get actually logged into the server in a few minutes, and you'll see that you even have IntelliSense to help you choose from a drop-down list different data types and so on when you go to define fields, right, in an actual database table. But just looking at the data gives you an idea, okay, what kind of a data type might I use to store this particular column? So looking at that first department code, okay, it definitely is not an integer, right? It's characters, so a string of some sort. And one of the things that stands out is you see all the values are always 4 letters, 4 characters. So there's some advantages to, if you can be confident that a text field will always be the same size, then there are fixed size strings that we can use. Okay? Char 4 in this example would be a good one. Char for character 4, right? Look at the next one. It is a variable length string, right? They're all the same. Sometimes you have room for more or less. So in a case like that, we usually think about what's the biggest size we're going to need. Okay? No point going overboard, right? Reserving memory in the system for things that will never be filled up. But you want to make sure it's big enough as well. So it'll be some sort of a variable string, and usually you look at the data, figure out how big you need, and add a bit of extra, just in case, right? Department budget. Now there's a choice there, right, between, there are all different kinds of numbers. Some of them are specifically for currency. In fact, SQL Server has money and small money. Small money, you know, rattles in your pocket. No, that's not true. Small money and big money, or money, are just, you know, how big a number do you possibly have to hold? Again, why go to something hugely massive if you're just going to have a smaller amount, right? Because it changes how much room it takes to store that information in the end. But there's other choices for decimals as well, and that's one of the things I don't want to, you know, give away any spoilers for this exciting movie on data types you're going to watch. But there's a discussion in there about why you might choose something like decimal as opposed to money, but I'll leave that up for you to figure out. Okay, so those are the next thing you do is you look at the data, you figure out, okay, what kind of data types am I probably going to go with for storing each column, right? And that's where having the data laid out kind of helps. So we have columns and we have fields or rows, so columns or fields, and we have rows of data, and away we go. So each row is often called a record. Okay? The table has records in it. Okay. And the other thing we talked about the other day is one of the hard and fast rules of relational databases is you need to be able to uniquely identify each row or record. So it might be a combination of fields that you decide would make up a good unique identifier. Think about if you had students, right? First name and last name and middle initials and phone numbers and so on. What would you choose out of that to be a unique identifier? What about the last name? Will that do the job, do you think? No. Lots of people with the same last names.
IDs, student IDs.
Sorry?
Student ID number.
Student ID number. Ooh, all right. You're jumping right to the meat of it, eh? Okay. I didn't mention that one as one of the possible columns.
Phone numbers.
Yeah, but that's what we're going to get to. Phone number might work, but you know, you might have 2 students that live at the same place and share a phone number.
Initials? Like all 3 initials of them?
You can start doing that. You say, okay, maybe the initials of the first name, middle name, and then the last name type of thing. Think about your Blackboard user IDs right now, right? It probably has an initial, then your last name, and some number behind it, right? Because there's been 16 D Stovels there already, so I'm going to be D Stovel 17, right? You know, that's one approach that can work. So you can combine fields, you can combine concepts together, or you can just generate what is often called a surrogate key. It isn't really a descriptor, right? As an attribute, it doesn't describe anything about the actual entity, about the student, okay? But it's an artificial number we've created just to keep track of that one student. So instead of being a descriptive key, we call it a surrogate key instead. Okay? So, you might come up with one thing or another. In the case of our department here, it kind of looks like our department code, as we discussed the other day. Looks like it's a good candidate already to be a primary key. One column, it's always nice to just use one column as opposed to multiple columns, right? And it looks like it does the job. So if you agree with the client, because they're the ones that write the check, then yeah, we just agree we'll never make two departments with the same department code. Done, right? Way you go. Okay. So the next thing we usually do then, once we have our model, when you're thinking about data types, is we actually make this table design chart. You will be doing this on your first test, just to give you an idea, okay? We're doing a model, and we're doing a table design chart. So these table design charts, usually you put the name of the table up top, and then in just 3 columns, we list the fields, what we're going to call them, the data types, and of course some data types have a size and some don't, okay? For example, somebody mentioned integer earlier. You might just say int. You don't put any size number behind it. An int is an int. If you want a bigger integer, believe it or not, you use big int, and so on. But you'll get used to the SQL Server data types in a little while. And then the last column is for constraints. So the most obvious one that every single table must have is that primary key, right? But we're going to learn about other constraints later on as well. You might check that the gender, right, is only M, F, or A, right? Things like that. Okay. So, in terms of the size, before I go on, we talked about because the department code was always 4 characters, good candidate to be something like this, a char 4. 4 being the size in terms of the literal number of characters. The name, varchar 30, allowing up to 30 characters. Doesn't have to be, okay, but it means we have room for that if we need to. Decimal, how decimal works is the digit before the comma is the total number of decimal places the number can hold, and then you say comma, and how many will be after the decimal place. So a 9, 2 would give you 7 decimal places in front, then your period or decimal place, and 2 afterwards. And that probably will handle all the budgets for this company. Okay? And away you go. So that's the next thing. After that, you'll probably go to the database and start actually creating the tables. Okay?
So, sorry, about the last slide. So that's 9 characters altogether, but the comma dictates how many after the decimal point.
That's right. Yeah. So 9
7
place.
Okay.
Yeah, places for digits.
Okay.
Up to. Yeah. Okay, good. All right. So in relational databases, and you hit on this perfectly earlier, we really have these 3 main types we're going to talk about, right? String or character data types, numeric, dates and times, and then there's all kinds of other things. So you can hold things like pictures or video files or, the Encyclopedia Britannica in one field, right? Things like that. So there's other things as well, and there's actually spatial data types, so that if you're going to map out the West Lincoln, right, and be able to write a query and say return all convenience stores in West Lincoln, right? You need spatial data types are the kind of geographical work and so on. So, these systems are capable of a lot more than we just think of at first from a simple business point of view. So we're going to focus on the first 3, and that's going to be as far as we take it in this term. Okay, so in terms of these character data, we really just have the 2 main types, fixed length and variable length, right? So we'll often call those char and varchar, var meaning variable. Now, one of the things that's going to confuse you is pretty soon if you start looking at code samples, you'll see a lot of them have the letter N in front, N-char as opposed to char, and varchar, and so on. Any guesses as to what the letter N stands for?
Numbers?
You'd think so. That would be an excellent idea. It's a Unicode. I don't know why. I guess they ran out of letters, so instead of using U, Unicode came along a number of years ago because up to then we had the ASCII character set. There was a limited number of characters that you could create in a computer, and each one had a code, a byte, right? Actually, you used 2 bytes, and that would give you so many characters you could produce on the screen or keyboard or whatever. But of course, a lot of languages in the world have a lot more characters than that. You know, even simplified Chinese or different ones like that, various Indian dialects and so on. So they've gone to a Unicode character system. Basically, you have twice as much room to store each individual character. So it takes a lot more room to store Dave Stovall in Unicode than it does in normal ASCII characters. But on the other hand, using Unicode means you're international, right? Your application would be ready to be easily converted to work in using languages from all over the world. So that's why you sometimes see N. And you know, really these days you're almost getting to the point where you might as well always use Unicode characters, unless you know that this application is going to be used locally here and never go anywhere else, right? Okay. So basically that's it. So the number after char or in varchar is the size, right? Of course, the implication is a little different with char. As I said, whatever you put there, every field will always be exactly that many characters. If you don't enter that many, it will pad it with spaces. Because it always fills it to that exact number of characters, even if you don't supply that many. Varchar is different. It will actually, it stores and it uses an extra couple characters to actually note how long the string is. And then it stores the actual data. So that's how it knows how to read it, right? Okay, now both of these though, at least varchar also has an option, instead of saying a number, you can just say max. If you say varchar max, well, that's where you can fit the entire encyclopedia, the text of the Encyclopedia Britannica inside the one field. To hold, I think it used to be 2 gigs. I think it's even bigger now of data, just about, or megabytes, anyway, megabytes. Lots and lots of room. Okay, so for chars, you can go up to 8,000 characters in a char, which is probably more than you'll ever need for a fixed length field. And that's about it, right? So chars are often used for things that don't even look like characters, even like bank account numbers, social insurance numbers, OHIP numbers, things like that that always are like 9 digits or 10, whatever. Even though it looks like a number, we might store it as a char instead. Because sometimes it saves you, it's more efficient sometimes, because everything gets turned into a character at some point going back and forth. Yes?
You have nchar, like the Unicode one you were talking about. You're saying that it's double the, like, would it still be nchar4 or would it be different?
Excellent question. Let me clarify. It'll still be an nchar4 to hold 4 characters. It's just physically in the actual hard disk, it will take twice as many bytes of storage space to hold it, because every character is allowed twice as much. Okay. All right. So in general, if you're certain it'll never be anything but the one size, then char is a good choice. Varchar, as it says, up to n is the maximum size, or you can simply say varchar max. And I think it says here, okay, 2 gigabytes of data. So that's an awful lot of text to go into a varchar max, right? Kind of overkill for a last name for most people. Okay? All right. That's a lot of characters. Things that will typically go into a varchar max well, just huge amounts of text. There's a var binary max that's commonly used to store pictures. Because you can encode a photograph or even a video file or things like that into a var binary max. But anyway. All right. The actual length plus 2 bytes. Okay, that's how much room it takes to store it on the hard drive. As I said, 2 bytes are used to basically track, okay, just so I know how many characters are in this particular string. And that's basically it. Varchar max for non-Unicode variables that exceeds 8,000 bytes. So if you need something more than 8,000, then you have to go to the max. Okay. So just reviewing our department table then, as we said, char 4, varchar 30, decimal 92, and as I said, the homework video will discuss that. I would not, if you want to test just said money, I will not take marks off you, even though this is probably a better choice, but you know, it's valid to choose simply the data type money as well. Okay? All right, so let's see then how we would actually create a table to hold this department data. Now for this, I'm going to pause the video and I want everyone to test their login. Did you all review how to log in here at the college? Okay. All right. Well, I'm going to stop the video.